Microservice architecture enables independent scalability of applications by breaking applications down into smaller services. Microservices have emerged as a popular architecture for building scalable and flexible applications. Instead of building a monolithic application, microservices enables developers to break down an application into smaller, loosely coupled, and independently deployable services. These individual services can be developed, deployed, and scaled independently, making complex applications easier to manage and maintain. The cloud offers two substantial advantages: adaptive resource allocation and cost optimization. Cloud platforms can automatically scale resources based on the microservices' needs, eliminating over-provisioning and wasted resources. This presentation delves into how databases, data mesh, and observability can be integrated with microservices to maximize the effectiveness of microservices.
In the past, monolithic systems relied on a single database to store all of their data, but with the rise of microservices, one database per service is becoming the norm. Having one database for each service allows you to pick the best database for the job. Some services might need a relational database, while others might require a NoSQL database. Microservices allow you to choose the right tool for the job. The cloud makes it possible to use many databases at once without the need of expensive hardware. Managed database services with automated maintenance makes it easy to set up and maintain databases in the cloud. And with cloud-based databases, you don't have to worry about scaling, backups, or security. In short, microservices and cloud technologies have changed the way we think about databases. One database per service allows for greater flexibility, and the cloud makes it possible to use many databases at once.
Data mesh is a modern approach to data management that solves challenges faced when using traditional centralized data platforms. Data mesh has a focus on treating data as a product. Data is not just a passive resource that is stored and processed, but an active asset that is designed, built, and delivered throughout the organization. Instead of having separate teams of data engineers who are responsible for extracting, transforming, and delivering data from various sources, data mesh empowers domain experts who build operational systems to also produce data products for other business domains. Microservices breaks down applications into small and easier to manage services, which helps produce data products that are consistent, reliable, and accessible across the organization. Leveraging the advantages of microservice architecture such as scalability and autonomy, data mesh enables domain experts to create and maintain data products that are aligned with business needs and goals.
Now, let's talk about observability in terms of how it is different from more traditional monitoring. Monitoring typically provides a limited view of system data focused on individual metrics. This approach is sufficient when system failure modes are well understood, because monitoring tends to focus on key indicators such as utilization rates and throughput. Monitoring indicates overall system performance, whereas diagnosing microservice architectures with multiple components and array of dependencies is challenging, as different components and services interact with each other dynamically. Monitoring is helpful when we understand how systems fail, but as applications become more complex, so do their failure modes. It is often not possible to predict how distributed applications will fail. By making a system observable, you can understand the internal state of a system, and from that, you can determine what is working correctly and what is not working correctly and why. Observability is understanding what's happening inside of a system from its logs, metrics, and traces. Systems are observable when they generate and readily expose the type of data that enables you to evaluate the state of a system. Using special tools and techniques such as monitoring tools like Nagios, logging tools like Graylog, and distributed tracing tool like Eiger, and metric tool like Prometheus can help with observability in microservices. By using these tools and following the best practices, we can maintain system integrity and enhance the observability of complex service-oriented architecture systems.
Microservices paired with custom databases and data mesh create data products that meet business goals. Prioritizing observability ensures optimal performance and early access issue detection, reinforcing system integrity. Databases, data mesh, and observability integrate with microservices for scalable, efficient app development.